Good day, everyone. We are the Group 3. In today's data-centric world, the ability to effectively interpret and utilize visual representations of data is a critical skill for decision makers across various industries. At the heart of data visualization lies the bar graph, a powerful tool for conveying complex information in a simple and accessible format. Throughout this presentation, we will delve into the fundamental concepts of bar graphs, exploring their structure, interpretation, and practical applications. We will also explore the history and more understanding about the bar graph. We also have example problems that will surely help you understand more. Their utility spans across diverse fields like economics, statistics, science, and business, aiding in straightforward comparison, trend analysis, and pattern recognition. Thereby, facilitating effective data communication is important. So, if you want to know more about bar graph, continue watching this video.
A bar chart or bar graph is a chart or graph that presents categorical data with rectangular bars with heights or lengths proportion to the values that they represent. Several experts and sources say William Playfair deserves credit for the development of the first bar chart in 1786. However, this statement appears to be misleading or, if it not wrong, at least just a part of the truth. William Playfair was born on September 22, 1759 and died February 11, 1823. A Scottish engineer and political economist, served as a secret agent on behalf of Great Britain during its war with France. The founder of graphical method of statistics, Playfair invented several types of diagrams. In 1786, the line, area, and bar chart of economic data, and in 1801, the pie chart and circle graph, used to show part-whole relations as a secret agent. Playfair reported on the French Revolution and organized a clandestine counterfeiting operation in 1793 to collapse the French currency. According to James R. Vinegar and Dorothy L. Rubin explain, this bar chart was the first quantitative graphical form that did not locate data either in space, as had coordinates and tables, or time, as had Priestley's timelines. It constitutes a pure solution to the problem of discrete quantitative comparison. So, even if William Playfair was not the one to invent the bar chart, we must admit at least his pioneering role in implementing and popularizing the idea of graphic depiction of quantitative data, and still being one of the first bar chart makers in the history.
A bar graph, also called bar chart, is a graphical display of data using bars of different heights. It can be vertical or horizontal. The primary feature of any bar graph is its length or height. If the length of the bar graph is more, then the values are greater than any given data. There are four types of bar graph, namely vertical, horizontal, grouped, and stacked bar graphs. So vertical bar graphs represent grouped data with bars along the y-axis, where the height of bars corresponds to the data values. Next is horizontal bar graphs, represent grouped data with bars along the x-axis, where the length of bars indicates the data values. Next is grouped bar graph, also known as a clustered bar graph, compares discrete values for multiple objects within the same category. It combines total instances into single bar using a single color to represent each series. This graph can be presented both vertical and horizontal. Then last is stacked bar graph, also known as a composite bar chart, divides the total into parts represented by different colors. It facilitates easy identification of categories, with each segment labeled to indicate distinct parts of the whole represented by each bar.
A bar graph commonly referred to as bar charts, is a graphical representation of data that shows the values or quantities of several categories or groups using rectangular bars or columns. The height or length of the bar indicates the amount or frequency of the data it represents, and each bar usually represents a different category. Bar graphs are useful tools for comparing data sets, seeing patterns, and secondly, and clearly presenting categorical data. They are frequently used to distribute knowledge and insights from data analysis in a variety of sectors, including statistics, economics, science, business, and education. In a bar graph, the horizontal or vertical axis represents the categories or groups being compared, while the length or height of each bar indicates the corresponding value or frequency. Bar graphs can be oriented either horizontally or vertically, depending on the preference and the nature of the data being presented.
These are the 5 steps on how to make a bar graph. Step 1. To collect data. The first step in drawing any graph is to collect data. Since it's a bar graph, it is a comparative study. Make sure you collect data for all the categories. And the second step, to draw the axis. In any graph, there are 2 axes. Draw the x-axis and the y-axis. And step 3, label the axis. On labeling the axis, first label the x-axis on the x-axis. We represent the categories. For example, we label the names of chocolates. For example, the A, B, C on the x-axis. Next, label the y-axis. To do this, take the highest frequency and plot the points on the y-axis accordingly. Fourth step, draw the columns. Finally, we draw the bars, and generally the bars are not connected or continuous. Now, we extend the bars from the base value to their corresponding frequency, and if the value falls between the plotted frequencies, take an approximately point between the two. And the last step is interpret the data. Once the bar graph is complete, we can interpret it and we can find out the most and the least preferred choices. We can also identify the outliers. And that's all.
Sample problems and solution. The table displays the number of bicycles produced at the factory from 2015 to 2016. So year 2015 to 2019, a number of bicycles manufactured. So from 2015, number of bicycles is 800, and 2016, number of bicycle is 600. 2017, number of bicycle is 900. 2018, its number of bicycle is 1,000. And 2019, number of bicycle is 1,200. So here's a question. Create a bar graph to represent this information and select your preferred scale. And the next question is, which year had the greatest number of the bicycle produced? And the third question is, which year had the least number of the bicycle produced? So the solution here is, at the low number of bicycle this side, and here is the years 2015 to 2019. So 2015 has the 2015 is an 800, 2016 is 600 of bicycle, 2017 is 900, 2018 is 1000, and 2019 is 1200. So which year had the greatest number is bicycle produced? The greatest number of bicycle produced is the year of 2019, and the lowest bicycle is year 2016. So the bar graph given for the information is above. So the year 2019 is predicted by the bar with the highest height as a result. As a result, the highest number of the 1,200 was sold in 2019 bicycles. So the year 2016 is illustrated by the bar with the shortest height as a result of 2016. A minimum of 600 bicycles were sold.
Another example is this graph which represents the nursing exam pass rate from 2019 to 2023. The y-axis represents the number of exam pass rates and the x-axis represents the year. So in 2019, 70% passed the exam. In 2020, 76%. In 2021, 80%. In 2022, 87%. And in 2023, 90%. So now that we have already identified its percentage, we will proceed with answering the question. Question number 1. What is the purpose of the graph? So the graph's purpose is to clearly illustrate nursing students' exam pass rate over a 5-year period. Question number 2. Which had the highest passing rate from the previous year? So the graph indicates that 2023 had the highest passing rate from the prior year at 90%. Question number 3. Which passes with the lowest percentage? So 2019 had the lowest pass percentage from the prior year at 70% of rate.
So here are the questions using the bar graph provided. First question, the total number of students in each class. So as you can see in the bar graph provided, you can easily determine the number of students in each class. So in class 1, there are 100 students. In class 2, there are 90 students. Class 3, there are 100 students. In class 4, there are 80 students. Class 5, there are 120 students. Class 6, 90 students. Class 7, 70 students. And class 8, there are 50 students. So example number 2. The bar graph depicts the number of students in various classes at a school. So as you can see, the bar graph is already given. The y-axis represents the number of students that ranges from 0 up to 150. And the x-axis represents the classes from class 1 to class 8. Question number 2. The overall number of students from grade 6 to 8. So you will add the number of students from class 6 to class 8. So the class 6 has 90 students, class 7 has 70 students, and class 8 has 50 students. So the sum of 3 classes is 210. So question number 3. The overall number of students from class 1 to class 8. So you will add the number of students from class 1 to class 8, and class 1 has 100 students, class 2 has 90 students, class 3 has 100, class 4 has 80, class 5 has 120 students, class 6 has 90 students, class 7 has 70, class 8 has 50 students. So overall, there are 700 students in a school. So question number 4, the number of students in a class on average. So the number of students in a class on average is equal to the total number of students divided by number of classes. So in the graph, there are 8 classes, and the total number of students we computed is 700. So 700 divided by 8 is equal to 87.5. So the average students in a class is 87.5 all in all. Thank you.
Hello everyone, I am Cyrel Rosell, and I will talk about the interpretation and answer from the previous examples. So first, the bar graph's title, which is displayed at the top, indicates what the graph represents, such as the quantity of bicycles manufactured in example 1, the passing percentage of nursing exams in example 2, and the number of students from various classes in example 3. A vertical bar graph is displayed in these 3 examples. The category and its label are located at the bottom of the graph's x-axis, while the scale and label are positioned on the left side of the y-axis. Further, the second and third examples include legends, which are optional visual elements used to identify various data groups in the graph. A representation of a factory's manufacturing output over several years is shown in example 1. The following years can be viewed as categories 2015, 2016, 2017, 2018, and 2019. The highest annual production of bicycles was reached in 2019 with 1,200 total bicycles, while the lowest annual production was produced in 2016 with 600 total bicycles. We can also show that the production fell between 2015 and 2016, but then rose in the years that followed. The pass percentage for nursing exams from 2019 to 2023 is presented in example 2. The 5 categories are 2019, 2020, 2021, 2022, and 2023. The bar chart reveals that the highest pass percentage happens to be in 2023 with a 90% passing rate, and the lowest pass percentage comes in 2019 with a 70% passing rate. The annual percentage of nurses passing their exams appears to be rising steadily. The third example displays how many students have been enrolled in various classes. The legend displayed 8 categories with a range of 1 to 8. With 120 pupils, Grade 5 has the most students, while Grade 8 has the fewest with 50 students. Grades 2 and 6 have the same number of students, which is 90. Regarding the problem B, the total number of students in grades 6 to 8 is 210. Simply add 90, 70, and 50. To answer the question C, we'll need to add them all together. So 100 plus 90 plus 100 plus 80 plus 120 plus 90 plus 70 plus 50 is equals to 700 students. We only need to divide the total number of students by the number of classes to answer the last question. Thus, the average will be 87.5 after dividing 700 by 8. That would be all for the interpretation and data.
So, in conclusion, bar graphs are a commonly used method of visually presenting data. They consist of rectangular bars where the length or height of each bar corresponds to the quantity it represents. Therefore, bar graphs are effective tools for presenting categorical data in a visually appealing and easy to understand manner. And they allow for a quick comparison between different categories and are particularly useful for showing changes over time or comparing different groups. And moreover, bar graphs are versatile and widely utilized across various fields including economics, finance, education, science, and more. They offer a straightforward way to convey information and making them a popular choice for both professionals and lay people, whether they are illustrating sales figures, surveys responses, or scientific data. That bar graphs provide a clear and a concise means of communication. That's all. Thank you.